Okay, so last video we looked at the two main parts, which were finding area under a normal curve and finding the x values or z values on a normal curve. Now, in the last section, we did that on a standard normal curve. So the mean was 0 and the standard deviation was 1. Or I should say on the last video, we did those two problems on the standard normal distribution. So when the mean is 0 and the standard deviation is 1. Now what we're going to do is we're going to transition to other types of normal distributions and basically do the same two problems, but with other types of normal distributions. Now, other normal distributions are pretty straightforward. We just have a different mean and different standard deviation. Okay? If we wanted to, we could do very similar problems, like finding the probability that you select something at random and it has an x value between 9 and 15 if the mean is 12 and the standard deviation is 3. So if we did that, well, we already know that if we're using probability, we're trying to find probability. Probability is area under the curve. We know this is a normal curve whose mean is 12 and standard deviation of 3. So we can just use the normal CDF function again. Our lower value clearly is 9. Our upper value is 15. Our mean is 12. And our standard deviation is 3. So normal CDF, lower is 9, upper is 15, mean is 12, standard deviation is 3. Now, I want you to type this in real quick. If you need to, push pause on the video. What you will notice, again, hopefully you did that, is that the probability of getting between 9 and 15 on this normal curve is 0.6827. Now that should look really familiar because that was the exact same probability we got when we were doing the standard normal curve and trying to answer the problem, well, what is the probability that on a standard normal curve we're within one standard deviation of the mean? So you would have went lower -1, upper 1, 0 is the mean, standard deviation is 1. So hopefully you remember that. Here's my point. Here's the reason I bring this up. Notice that what this really is, 9 is one standard deviation below 12. 15 is one standard deviation above 12. So one method the book will use, and many books will use this method, they'll use a method which translates everything from x values into z-scores and then find the probability based on z-scores. And if we didn't have a nice calculator that found the probability for us, this is the technique we'd have to use because we can't memorize a million different normal curves that could have different means and different standard deviations. So if we had a table, we'd do the standard normal curve and then we'd translate everything into z-scores and use the standard normal curve for that. Now, good thing for us, our calculator can do this problem. So without having to, so moving forward, we don't have to translate into z-scores. Okay, so the point of this exercise is just to see that yes, we could have done this whole same problem using z-scores. We don't have to, we're not going to in this class. We're just going to use x values and use the various means and standard deviations that we're given. So what I'd like you to do is try the next problems on this slide. Push pause on the video, find the area or probability between 10 and 14. All right, hopefully you went ahead and did that. Push pause on the video. Don't forget, lower bound, upper bound, mean, standard deviation are my inputs. So let's go to the guided notes here. So if I was to type in the normal CDF function, probability of getting between 10 and 14, lower bound is 10, upper bound is 14, my average is 12, my standard deviation is 3, so 0.4950. So almost 50% chance that we get between those two numbers. If, again, this is all just trying to remember how to do this. If we go x greater than 5.7, remember what that did. That gave us a lower bound of 5.7, an upper bound of some really big number. Actually, it's positive infinity. So let me type that in here. So lower bound, geez, 5.7. My upper bound is positive infinity. Again, we can just pretend that a really, really big number is positive infinity. My mean is 12 and my standard deviation is 3. So what I got is 0.9821. Okay. Now again, you can play around with these upper numbers. You know, 100,000 would be a really big problem, really big upper number in this problem because our mean is 12 and our standard deviation is 3. If our standard deviation was a million, obviously 100,000 would not be very big compared to a million. But since our standard deviation is 3, 100,000 is a very, very big number. Lastly, hopefully you remember how to do lower bounds as well. So we'd say, well, lower bound is negative some really big number. Again, I'm using 100,000. If you would rather use 999,999, something like that, negative a really big number, then that's fine. Upper bound is 13.4, mean is 12, standard deviation is 3. So I am currently typing that in to my calculator, and I got 0.6796. Oops. Oops. There we go. Okay, so 0.6796 with that normal CDF. So basically, the nice thing here is when we have a different mean and a different standard deviation, our normal CDF is going to work exactly the same. We just have to put a different mean other than 0 and a different standard deviation other than 1. Okay. Similarly, when we go and find the x values, well, these will truly be x values. So when it says find the x value, which is greater than 70%, 78% of all other x values, again, we're going to use the same methodology. We're going to use inverse norm, and then area to the left, and then a mean and a standard deviation. So if I have a mean of 12 and a standard deviation of 3, all I need to do is use area to the left, meaning from negative infinity up to whatever value I'm looking for, and then my mean and my standard deviation. Let's go ahead and do that. Now, be really careful on the wording. We want to find an x value which is greater than 78% of all other x values. If you think about what that has to mean, that has to imply that wherever our x value is, 78% of all the other x values have to be below it, right? 78% are below our x value. Now, as far as inverse norm goes, remember we're always using the area to the left. So when I go to type this in, I draw my picture. And I would say this is inverse norm. The area to the left is 0.78. My mean is 12. My standard deviation is 3. And so the x value that you get is 14.32. So the x value, which is greater than 78% of all other x values, is 14.32 if the average is 12 and the standard deviation is 3. What I would like you to do is try the next two problems, finding the x value, which is less than 56% of all other x values, and finding the x value, which is bigger than the average, so that 37% of the values are between that x value and the mean, the average. Go ahead and push pause on this video, draw that curve, make sure that you draw that curve every time, but push pause on this video and come back and see if you did it right. Okay, so hopefully we did that. We want to find an x value which is less than 56% of all other x values. So less than 56% of all other x values. If I were to draw this on a curve, what I would draw would look something akin to this. My x value would be less than 56% of all other x values. By the way, when in doubt, draw the curve, and if it doesn't sound right, doesn't look right, draw it two different ways and see if curve A or curve B is the right one to use. Oops, sorry. So by the way, so we're using inverse norm. If 68% of all the other x values are bigger than this one, recall that the area that I need to put in is, well, what I have in yellow here. And if 56% is the blue, then the yellow has to be 44%. And there we go. Moving on, the area that I need to plug into my inverse normal function is 0.44. So I go inverse norm, 0.44, then 12, then 3, and hopefully you get that the x value you were looking for is 11.55. Again, I'm rounding these all to 2 decimal places as far as the x values go, and as far as the probabilities go, I always go to 4. All right, so last one here. We want to find an x value which is bigger than the mean so that 37% of the values are between it and the mean. Okay? We're going to undo this. So what are we saying? We're saying our x value needs to be bigger than the average. Well, the average is right here. And we know that that line there is the line of symmetry about the normal curve. So we want our x value, wherever it happens to be bigger than the average. We want this area, the area between the average and the x value, to be 37%. Doesn't have to be perfect, but there you go. And well, we are going to look for the area from negative infinity up to x. So what we're going to have to do is we're going to have to take this area in here, the area that I just shaded in green, plus the blue area. Again, the area in green has to be, oops, 0.5. Ugh, sorry about that. So the area in the green has to be 0.5 because it's the left half of the curve. So if you look at the total green plus blue area, green plus blue is going to give us 0.87. So together these two areas are the area from negative infinity up to x. So the area that we're looking for is 0.87. 0.87. And so what that means is that the inverse norm should be 15.38. So the x value that I'm looking for is 15.38. Okay? So that's pretty much it. That's the whole thing. And normally what's going to happen is we're not going to be given a problem like this necessarily, saying, hey, the mean is 12, the standard deviation is 3, find these probabilities, or the mean is 12, the standard deviation is 3, find these x values. It'll probably be more something along the lines of an application or a word problem. So according to a company, this Alvarez and Marzal, the average age of CEOs is 56 years old. That is for publicly traded companies. The variable is normally distributed. Assume the standard deviation is 5 years. And we're going to find the following things. Find the probability that a randomly selected CEO will be between 52 and 60 years old. You can see the data there. If you want to click on the site, you can find it there. So here's what we're going to do. Basically, it's pretty straightforward. The average age of a CEO is 56 years old. So we know that the mean is 56. We assume this is normally distributed, and we're assuming that the standard deviation is 8. Okay? So basically we know we're on the normal curve. We have a mean of 56 and a standard deviation of 8. And this first question asks for a probability. What's the probability that if you select a CEO at random, they're between 52 and 60 years old? So here's how I would explain it. Find the probability that, let's do this first. So for all of these, basically, we know things are normal. We know we have a bell-shaped curve. We also know that our average, that our average here is 56 and our standard deviation is 8, right? Because that's just given to me in the problem. So what we're looking for in this first problem is a probability. And basically, it's almost exactly like these probabilities. To find that probability, we're going to be using a normal CDF function. So find the probability that we're between 52 and 60. So here's how we could shorthand this. What's the probability that we select a randomly selected CO, that's the X. What's the probability that that age is between 52 and 60? So since we're finding probabilities, we're using normal CDF. Lower bound is 52, upper bound is 60. My mean, we just said, is 56, and my standard deviation is 8. So that's it. That's the whole kit and caboodle there. Probability between there is normal CDF. We know how to calculate using a normal CDF. We've done that a number of times before. 0.3829. So 0.3829 is the probability that a randomly selected CEO will be between 52 and 60 years old. Hopefully that makes sense. Let's do the next one. What's the probability that a randomly selected CEO will be under 45 years old? Now, one thing about this, under 45 years old. So what's the probability that a randomly selected 3Os, I would call this less than 45. Okay, again, it wouldn't matter if we had an equal, less than or equal to, or just less than. It's all the same in the wash when we have a continuous curve. Now, pretty straightforward that we're saying x needs to be smaller than 45. So we're going to go from a really low number, like negative a million, up to 45. My average age is 56, and my standard deviation is 8. Now, as you type this in, I want you to notice that it is kind of silly to have the age go all the way down to negative a million, okay? Obviously, we can't go that far down, that young in age, but on a normal curve, we do go down towards infinity. So in practicality, yes, 0 would have been the lowest age we could have gone to, but instead of trying to like figure out when we should go to 0, when we shouldn't go to 0, what, all these other things, we're going to keep it the exact same way every time we do it. So we're going to go down to negative infinity, negative some really big number every time. Okay, whether that number makes sense or not is not our issue. We just go down to that size. Hopefully that makes sense, the idea there. Okay, so it's okay to go down to negative infinity, even though negative infinity is not a real age we can go down to. And then lastly, it says based on this information, 10% of CEOs will be older than what age? 10% of CEOs will be older than what age? So think about this. It's pretty much here we're given a probability, but I go back to that normal curve and say, gosh, 10% of CEOs are older than what age? So let me give you two options here. And I want you to think about it, because this is kind of what happens when you get stuck. If you get stuck thinking, well, which side of the curve is that? Go ahead and just draw the two curves. Say, okay, draw the two options. Whoops. So 10% will be older than what age? So there's some age here, there's some X value. Are we saying we're in the green scenario? Or are we saying 10% are older than what age? Is that in the purple scenario? Okay, so which one of these two scenarios? 10%, there's an age where 10% are older than that specific age. And hopefully, if you think about that, it's the green scenario. Okay, now don't forget when we plug things into our inverse norm function, we need the area to the left. So we need the area from that x value all the way down to negative infinity. So what I've shaded in there is orange. So that's the area we need. And if 10% is the green, well, 90% must be the orange. All right. So when we go and type this in, we're going to use that the x value is inverse norm 0.9, and then the mean is 56 and the standard deviation is 8. You could use 0.9 or 0.90 or whatever you want. And it turns out that only 10% of CEOs are older than 66.25 years old. All right, so about 10% are over that 66 mark, and about 90% are under that 66 mark. All right, so we did that first application. What I'd like you to do is I'd like you to try this second application. I want you to read this on your own and then try to find the question asked in this first bullet point, and then find the question we ask in the second bullet point and the question we ask in the third bullet point as well. All right. In fact, I think what's probably easier to read on a screen is a Word document. So that's what I'm going to do. I'm going to pull up the Word document. If you can't read that, you can always get out the guided notes yourself. So push pause on this video and then we'll come back and finish it. All right, so hopefully you did this on your own. Probability, first off, we have our average of 37,172. We're assuming we're normally distributed. Don't forget, that's actually a really important step that I've been kind of just glancing over. If this is not normally distributed, then we are up a creek and we couldn't use what we're using now. Okay, so we do need normal distributions here. So what are we saying? We're saying that the average is equal to 37,172, and the standard deviation we're assuming is 14,600. Okay. So first question asked, what's the probability that a college graduate owes 45,000 or more? So what is the probability that the college graduate owes more than or greater than or equal to $45,000? Well, we're finding probability. So probability is normal CDF as long as we're normal curve. 45,000 is my minimum number. Actually, let me do this without. My upper value is a really big number. So any really big number would do. Now, when I say a really big number, I mean really, really big compared to 45,000. Okay, if you put 100, obviously 100 is not big compared to 45,000. So we have to make sure that our number, whatever we type in, is big in comparison to the numbers we're dealing with. So extremely big numbers, I don't know what I put there, 10 million, 100 million, whatever. My mean is 37,172 and my standard deviation is 14,600. All right. And 0.2959 is the probability that you get something at random being above $45,000. Excuse me, new college graduate having debt above $45,000. So there we go. The next problem, again, hopefully you did this too. If you haven't, push pause and try it. Okay? But next problem says, what's the probability, whoops, that a new college graduate owes somewhere between 20,000 and 60,000? So what's the probability that 20,000 to 60,000 is what the new college graduate owes? So again, we're looking for probability. We're looking for normal CDF. My 20,000 is my lower number. My 60,000 is the higher number. My mean is once again 37,162. Oops, I forgot to type in 60,000 and 20,000. So 20,000 lower, 60,000 upper, my mean, my standard deviation, and I got 0.8213. So 0.8213 is the probability that a new college graduate owes between $20,000 and $60,000 of, has between $20,000 and $60,000 worth of debt. Now notice that that's a pretty big percentage, right? The $20,000 to $60,000 is saying 80% of college graduates have that much debt, 82% roughly. So that's a pretty staggering number there. Pretty big, high probability. All right. And there's all kinds of other things we could say about that, I'm sure. All right, it says if a new college graduate owes less than 90% of other college graduates, what do they owe? Now, first off, we should say this one's different. This one is not finding probability, but rather finding the x value. Okay, hopefully you read that. Hopefully you're read into that. So how does this work? Again, what are we going to do? We're going to have a couple of options. Apologies here. Either a new college graduate owes 90% less. Well, let me put it this way. Go back to reading. If a new college graduate owes less than 90% of others. So that one, think about this, owes less than 90% of others. Is the red area make sense? Hopefully you say no. This would be the value is more than 90% of the others. So what we need is the opposite. What we need is this college graduate owing less than 90% of others. So the 90% is here in red or maroon or whatever. Don't forget, I need the area from negative infinity up to x. So in this case, if 90% is this area, then 10% is that area. And now we know what to plug in for our inverse norm function. Let me write that down. So the x value we're looking for is going to be an inverse norm. The area from negative infinity up to that value is 10%. Again, 0.10 when you type it in. 37,172 is the average, and the standard deviation is 14,600. Put that in, and we see in order to owe less than 90% of everybody else, you have to get out of college with $18,461.35. Okay? So if a new college graduate owes less than 90% of other ones, then they owe about $18,461. Now, one thing I want to mention here, again, because we're going to wrap this thing up, is this. When we're doing these inverse norm problems, it's kind of hard to just read them and to decide what kind of look we're given. What sort of area is the area from negative infinity up to my x value? It's hard to figure that out because the obvious reason, the English language is fairly complex. So rather than trying to memorize a bunch of like, oh, if it says less than, do this, or if it says more than, do this. It's a lot easier to every time to draw a picture just like I did. It's a pretty crude picture. It's just, again, a bell curve. We know the mean is in the middle. And then, draw a little picture for your own benefit to do this because it's really easy to get confused. I can't tell you how many times people have turned in the tests and they've just totally bombed the inverse norm stuff. Okay, so because they didn't know what area to plug in. So make sure you know what area to plug in. Draw the picture, practice, practice, practice. Practice as much as you can. All right. So hopefully that makes sense. At this stage, we are done with the 6.1 notes. We're going to go on to the 6.2 notes in the next video.